Okay, so welcome to our first notes about chemistry. And this we're going to be talking about what is chemistry. It's just a basic introduction. So chemistry, so there's some words that we need to learn. These are some vocab words. These would be important things for you to write down. So the first word that we want to talk about is matter. And matter is the stuff that all things are made of. So it's anything, so like we watched on the video today, and the elements that make us up is called matter. So chemistry is the study of matter and the changes in the energy and the composition, or how it's put together, that take place within that matter. The word chemistry comes from the word alchemy, and alchemy was the precursor to chemistry. And alchemists studied the transformation of matter. So they felt like you could turn things like metals into other more valuable types of matter, like turning lead into gold, or if you're familiar with Rumpelstiltskin, turning straw into gold. So obviously many of these pursuits were unsuccessful. But it led to making some important observations. So even though alchemy wasn't very successful, it did give them some good observations, and it did lead us into what we now know as chemistry. So why should we study chemistry? For one thing, curiosity. It helps us understand the world. Food. It helps us know what's in the food that we are eating. Why do we need to eat that food? In clothes, what materials are clothes made out of? How are they made? Fuel, where are we getting energy for cars and planes, and how does that work? Where does it come from? Water treatment, how do we purify our water? Medicine, cooking, fire safety, right? There's some kinds of fires that if you throw water on them, it'll make it worse. So there are different kinds of fire extinguishers. That's kind of helpful that to know. Also because chemistry is fun. We're going to be doing some fun experiments. And there's many, many other reasons. Life relies on chemistry. So what is a chemical? We tend to think of chemicals as these harsh, cleaners and things. But what about things like water? Is water a chemical? How about milk? Is that a chemical? If it's in a beaker, does that make it a chemical? What about soap? So these are some of the things we're going to be exploring this year. Everything. Everything is a chemical. All of these substances, water, milk, soap, bleach, deodorant, liquid drainer, cleaner, it's all chemicals. Even if this is colored water in these beakers, those are chemicals. Yes, chemicals are dangerous, some of them, but obviously not all of them. A chemical, the dictionary definition means of or relating to chemistry or the interactions of substances as studied in chemistry. So what in the world does that mean? Well, let's go back. Let's look at matter. So again, matter is the stuff that takes up space and has mass. Everything is made of matter, but there are different types of matter with different properties. So we have mixtures, and we have pure substances. So something like tap water is an example of a mixture. So it has other substances in there, mixed in with it. Distilled water would be a pure substance because it's just water molecules. So a pure substance, and this is another one of those vocab words, is a substance that has a constant composition and a fixed ratio of elements. So what in the world does that mean? So for example, water is always made of 2 parts hydrogen and 1 part oxygen, nothing else. No matter, whether you get the water out of this, whether it's rainwater, distilled water, tap water, the actual water is 2 parts of hydrogen to 1 part of oxygen. Pure table salt is always 1 part sodium to 1 part chlorine. Pure substances have very consistent physical properties, like their melting point. So the melting point of a pure substance of pure table salt is always going to be the same. Whether you have, 1 grain of salt, 100 grains of salt, whether it's made from by one company or another company, if it's a pure table salt, it's always going to have the same melting point. Pure substances with more than one type of matter are difficult to separate. So they're really hard to separate those 2 parts or those 3 parts in the case of water. Now, you should know that 100% pure is almost impossible to achieve. Just because there are so many other substances in the air that you can't see, it's very hard to get a pure substance that's 100% pure, that has absolutely nothing else in it. So a mixture. A mixture is 2 or more substances that are mixed together but do not chemically combine. And they can be relatively easy to separate. Just about everything is a mixture. So if you think about the ingredients for a cake, like that would be a mixture. You could pretty easily take those things apart. So examples of mixtures are blood, tap water, salt water, salad, ice cream. So think about my favorite is cookies and cream. So, you can see the different pieces of the Oreo in the vanilla ice cream, right? So they're physically together, but they're not chemically together because you could pull out those pieces of Oreo. If you melted the ice cream if you put it in like a colander, and you melted the ice cream, right? The ice cream would eventually run out, but all the pieces of cookie would still be left. The atmosphere is a mixture. Milk, gasoline, dirt or soil, cake, those are all examples of mixtures. So there are 2 types of mixtures. The first one is a heterogeneous mixture. And the word heterogeneous, the root word hetero, comes from the Greek language meaning different. And so 8th graders, you'll probably remember when we talked about in biology the heterozygous. Remember, they had 2 different types of alleles, right? So the alleles were different. And we had that same root word of hetero. So a heterogeneous mixture is when 2 or more substances mix together, and they can usually be seen. They don't dissolve. So these M&Ms, right, if you think that each M&M is a different substance, right here they're mixed together, but you can see each different kind of M&M. The substances may not be equally distributed. So if you look over here, right, you've got this big clump of blue M&Ms up here, but down here, there aren't any blue M&Ms right here. So clumping or grouping can occur. They're easily separated. You could take this and separate out each individual color very easily. So some examples of heterogeneous mixtures are sand and water, right, which is a liquid and a solid. A carbonated beverage like soda or beer, which is a gas and a liquid. Orange juice with pulp in it would be a liquid and a solid. Water with ice cubes in it, again, you've got your liquid and your solid. Chicken noodle soup is liquid and a solid. Oil and water, right, which is over here, those 2 liquids don't mix together, and so you could easily separate them back out. A salad, right, you have a salad, you could very easily pull out the tomatoes, which I do because I don't like them, and the cucumbers, the carrots. You could take it all apart and make piles of all the different vegetables. Trail mix, again, granite, table salt and crystals and sugar crystals. So you could mix them together, but you could take them apart. The other type of mixture is a homogeneous mixture. And again, we see that root word of homo comes from the Greek language meaning same. So you'll remember this from 8th graders from last year, from homozygous, right? The two alleles were the same. So it's that same root word of homo. This is when two or more substances are mixed together and they can't be seen. So they do dissolve, and the substances are equally distributed throughout the mixture. They can be separated, but not as easily. So some examples are salt dissolved in water. So you can separate them, but it's harder to do. Soapy water, hydrochloric acid in water, alcohol in water, sugar dissolved in water, ammonia water, phenolphthalein dissolved in alcohol and water, the extracts of coffee beans, so when you make coffee, and the extracts of tea leaves, so when you make tea with the water. Okay, so now you need to go to Edmodo, to the Edmodo quiz, and take the quiz.